At the time, never before had a production Ford gasoline engine been as powerful as the 5.8-liter V8 in the 2013 Mustang Shelby GT500. This new evolution of the modular engine family was the most powerful production V8 in the world. That's quite a claim for a major manufacturer like Ford, but a perfect performance for its in-house performance group, the Special Vehicle Team. While SVT's corner office technical chief, Jamal Hamidi, notes that his team's goal was not to set a world performance record. They knew they had to go all out when upgrading the GT500 Mustang. Not only were the other guys in town working hard on their ZL1s, but Ford's Boss 302 was also approaching GT500 performance. The Shelby GT500, while impressively upgraded for 2011 with an aluminum block and 550 horsepower, was slated for a complete makeover as a 2013 model that goes on sale in mid-2012. This redesign of the GT500 is all-encompassing, covering handling, braking, performance, and aerodynamics. We suspect that the upcoming GT500 will still be a Mustang, but galloping so far ahead of the traditional pony car herd that it will ride thoroughbred exotics rather than everyday quarter horses. Its goal is to be the ultimate Mustang, and if it isn't, we'll eat its 10-rib lower belt without butter. When SVT sat down and set specific goals, they arrived at engine targets of 650 horsepower, 600 pound-feet of torque, a nominal 6,250 revolutions per minute redline, supported by the ability to temporarily rev to 7,000 revolutions per minute and not induce a gas guzzler tax penalty. While we're not privy to Trinity's financial constraints, the 5.8 is a small displacement engine, so costs had to be tightly controlled. Exotic solutions would require relatively few customers to pay, and we're sure Ford management is determined to keep the GT500's sticker price competitive. What SVT did to arrive at the 5.8 was to start with the 5.4 GT500 engine and modify it as needed to support the initial 640 horsepower target. As the program progressed, it soon became clear that 650 horsepower would be just as easy to achieve given the changes made, so the target was officially raised to 667 horsepower. Like the 5.4, the 5.8 is an all-aluminum V8 with dual overhead camshafts, 4 valves per cylinder, a belt-driven supercharger, and air-to-water charge cooling. Like the 5.4, the 5.8 does not use variable cam timing, let alone dual independent cam timing, nor does it use direct fuel injection. Indeed, the 5.8 uses the same basic architecture as the 5.4, meaning the basics like bore spacing, nominal deck height, guide bar width, cylinder head design, etc. are identical. However, scratching just below the surface of the basic architecture and the amazing amount of detail is different. It's these details that make up the story and are there to support the 4 main changes: more displacement, significantly higher boost, piston oil injectors, and higher revs. Several components are interchanged between 5.8 and 5.4. However, even if they physically bolt, the power of the 5.8 is in a different league than the 5.4. A quick measure of this is that the Condor 5.4 has 9 pounds of supercharger boost. The Trinity 5.8 is 15 pounds. It's a bit of a mystery how the SVT ended up at 5.8 liters. From a design standpoint, it's always easiest and least expensive to increase power with increased displacement, so the first step for an engineer was to add 20% more power to an already highly stressed engine is to make the engine bigger. A bigger engine is less stressed at a given power level, and when you're talking about the world's most powerful stock V8, a little less stress is a good thing. This means that marketing must have played a large role in the 5.8's push. There are a lot of glories in Mustang history surrounding the displacement of the 351 Ci, a displacement that changed to 5.8 liters in Detroit. Taking the history theme a step further, the 5.8 is a perfect step up from the 5.0 in the Mustang GT, so management wasted no time landing on 5.8 liters of displacement for the GT500 engine. Liner notes: the spray hole is special because it removes iron cylinder liners. This technology saves weight because the amount of iron lost is significant and goes where any Mustang could shed a few pounds, right over the front axle. But most importantly, in the 5.8, removing the liner thickness allowed for the absolute maximum bore that the aluminum block architecture would allow. The trick is that pistons and piston rings cannot live without a durable iron cylinder surface that does not seize. Bare aluminum is too soft to coexist with the piston and rings, so some other, harder material must be added to the bore of the raw aluminum. Many people have worked on this problem for decades, including Reynolds Aluminum 40 years ago in big block stock Chevy Can-Am engines. Porsche is another notable experimenter. These earlier methods involved adding the material to the cast aluminum along with wet sprays such as Nakisol that are applied after casting. Get shorty. Since the thermal activity in the 5.8 at full chat is probably enough to make the devil sweat, attention had to be paid to the cooling and oil systems. Specifically, SVT needed to verify coolant flow around the cylinders just below the block deck and also between the exhaust valve seats in the cylinder heads. At the bottom end of the block, the pistons are exposed to the heat and pressure of the diesel level and therefore needed oil cooling nozzles. When modernizing the cooling system, SVT turned to computational modeling of fluid dynamics. Perhaps the biggest need was to get the coolant between the exhaust valve seats, a path that starts in the block as the coolant flow is from the water pump through the block, up through heads, and out to the radiator. The existing 5.4 coolant flow directed the water up through the deck of the block and nicely around the exhaust valves, but not between them. This is where CFD proved particularly useful, allowing SVT engineers to determine the additional paths needed to route coolant between the exhaust seats at the correct speeds and flow volumes. These additional coolant paths in the heads had to be fed through new passages in the block deck. Hidden team. We never go to Ford Motor Company without being impressed by the scale of the company and the number of bright, hard-working people employed there. It's a feeling that cannot be described or addressed by listing everyone involved in a single engine project. Even at SVT, with a total staff of just under 50 employees, it's impossible to know everyone involved in the 5.8 engine. The 5th Gen Shelby GT 500 is a favorite among Ford fans and many car enthusiasts. Many believe the Trinity engine to be even better than the newest Gen 6 GT 500 with its 5.2-liter V8 maxing out at 180 miles per hour, while the Gen 5 has reached 200. This is one of many reasons. Thanks for watching. Let us know if you'd like us to cover any other engines. Until next time.